Hello, my name is Alexander Zhidev, and this is the video for individual assignment on building a neural network. So for this assignment, I selected one of the datasets from UCI machine learning repository called hepatocellular carcinoma dataset. This dataset has some information about patients with this type of liver cancer and whether they survived 1 year or not after being diagnosed, which we will use to build the model to predict cancer survival rates. In the dataset, 63 patients were marked deceased and 102 lived, so the dataset is a little bit skewed. So this is the model that I built in SAS Miner. And for my first concept, I would like to talk about what to do when a dataset has missing values. When I started exploring what data looked like in the dataset, I realized that it had some missing values, and I learned that there are some ways to deal with missing values in particular. We can fill the gaps by filling data using an algorithm calculated on the attribute. In this scenario, I was getting very low prediction accuracy when I first built the model, because in SAS Miner, if an observation contains a missing value, then by default that observation is not used for modeling by nodes. So I use this impute node to let SAS impute the values for me using the following algorithms to help me build a better model, which worked pretty well. For my second concept, I wanted to mention that when building the model, we have to make sure to appropriately split existing dataset into training, validation, and testing categories. It is important because training dataset is used to build several models, and in order to determine which model is best out of the ones built, we use validation dataset and select best performing model. Then we use the testing dataset in order to determine the accuracy of the model we build. Testing is paramount in data mining process. For our dataset, we split data on the following parameters. It's 50, 30, and 25 to ensure a better performing model. For my third concept, I wanted to bring up the concept of building a neural network model itself. When we want to build an accurate model giving us better predictions, neural networks is a good way to go. Neural networks consist of input nodes, hidden layer nodes, and output nodes, and use transfer functions to make accurate predictions. So in our model, I used this multi-layer perceptron algorithm architecture for the data model with 4 hidden layer nodes. And it's complicated to determine the weights of the sum of inputs for each of the nodes, as we need to do lots and lots of complex repeating calculations to adjust the model. But SAS Miner does all the model building for us very quickly using the backpropagation algorithm that I selected in this optimization tab. And so for my fourth and final concept, I wanted to bring up that when we build the model, we don't know how accurate it is. So we should use some of the accuracy-based metrics available to us to check and make sure what we build works. We can see some of the metrics in SAS Miner right here. I have them open. So first up, we can see that the misclassification rate that shows how often the model came up with the wrong prediction is about 27 to 29% right here at the bottom, which is not too bad. Comparatively, the mean square error right here is about 25 to 26%. However, misclassification rate, although it's the most basic metric, I think in this particular scenario it would be the better one to use for evaluation, because mean squared error metric is more useful in the scenarios where we try to predict some of the continuous variables and are trying to find out how close we got to the prediction of the actual value. In our case, we simply predict a binary categorical value of whether the person survives 1 year or does not. Another good method to estimate model accuracy would be to look at the confusion matrix given right here. Confusion matrix shows us how many false positive results, how many true positive, true negative, and false negative results we get. So in our data set, we know that the target variable is a little skewed, with almost double the number of people surviving past 1 year. Before cleaning up the data set and doing variable imputations, the model was very inaccurate, and this matrix was showing model's true positive rate of 0. However, having done some data cleanup, we can now see that the model accuracy is much better, and it's predicting more of the correct values. Like see in the validation, the true positive rate is pretty high, and true negative rate is pretty good. So in overall, it's about 70% accurate according to our misclassification rate. So these are the concepts that I wanted to cover in this video. Hope you enjoyed watching it and have a great day.